let's starting. Let's start it. Okay. So today we're going to talk about the first session in network structures and cloud computing, which is a practical foundation in cloud computing and hands-on experience with cloud tools. As you already saw, we started to work with the GCE, with Google Cloud Computing, but the principles that we are going to discuss in this course are generic enough, so one can apply it to any of the other public cloud offerings in the market. Few administration. The textbook, I hope that you had the chance to download it. I don't think you need to buy it. It's available online. This is the main textbook that we are going to discuss up to chapter 8. It's basically it's a synthesis lectures on cloud computing architecture, which is a pretty good one. Sometimes it's a little bit off, but I'm going to stay focused on the important aspects. Um, the cloud tools, you can use cloud GCE or you can use AWS. I prefer GCE because it's free. The grading, as far as grading is concerned, we're gonna have quizzes every between 3 and 4 weeks. It's gonna be 50% from the entire grade, 10% for the essay that you're gonna have every week, and 25% for the project, the final project, and 15% for the presentation. Yeah. Yes. Mm-hmm. Exactly, exactly how we do it. Exactly how we do it right now, right? We're gonna have a hangout session, and you're going to present your work. Okay? Mhm. GCE. So as I said, this course does not um, put emphasis in the specific cloud provider. We don't really care what is the public provider that you are using. However, um, GCE is something that provides whatever we need for this course, and moreover, one of the key ideas in this course during the rhythm of the course is that you're going to see that we are going to discuss problems, specific problems in high scale internet services, and GCE solved this problem by another offering which is called Kubernetes, a cloud software containers solution. Now, AWS has a similar solution. It's up to you. I think that you can succeed in this course very well if you use AWS, GCE, IBM, or even Microsoft Azure. So it's not so important. I will strongly suggest that you will use GCE just for the parity with other people in the class and with my exercise. But it's up to you. You're welcome. Okay, so let's talk a little bit about the definition of cloud computing, and then we're gonna double click on every part and see how it all get reconciled together into something that it's into a service. So cloud computing is basically a model for enabling convenient on-demand network access to shared pool of configurable computing resource. This is a mouthful of definition, but essentially, if you think about it, it's very similar um, any electric to the electric utility service, which is basically you have a device, right, which is your app, and in order to operate it you need to have some resources, and the resources happen to be in other devices, not app, electricity, right? You need to have electricity in order to operate it. So if you have an app, you need network, you need to store some information, photos, text, etc. So you need to have a storage, a digital storage, and you need to have a CPU, a computing processing. So basically, cloud computing is is more like a utility service that enable you to do to operate these app, i.e. the devices in the electric grid analogy. And the resources, as I said, network, compute, storage, applications, and services. The resources that we are talking about here are rapidly provisioned and released with minimal management effort or service provider interaction. What I'm saying, if I'm going back to the analogy to electrical grid, when you want to have electricity, you just plug it into the utility and you get electricity. You don't call anybody, you don't provision anything. It's basically available for you as an app, right? As any device. So this is the analogy. Now, it's not a bulletproof definition, but it's just to make it more simpler because, simpler. And the reason for that is that there is a lot of buzz around cloud computing, and everybody wants to be in the cloud business, and they all want to be, every person that has an app wants to put it in the cloud. So the purpose of this thing is just basically to decompose it and understand what cloud means in the most simple way. The value proposition and challenges that cloud computing provides, and I'm talking about public cloud in particular, is that it offers the promise of massive cost saving combined with increased IT agility. And what does it mean? It means that if you have an idea and you want to build this idea, to build a product around this idea, you don't have to actually go and purchase hardware and air conditions or lease something and get committed into some challenging obligations. You can simply go to AWS, GCE, and basically start working on it immediately from the time that you have that idea. You can prototype it, you can seek for a feedback, and if it's working fine, you can simply provision more resources and scale out your service. And this is basically the IT agility that cloud provides. It challenges many traditional approaches to data center and enterprise application design and management. What does it mean? It means that basically in the old days, it's still current days, when you want to you have a service, right, in the organization, and you need to operate the service in some ways. You have to The traditional approaches requires you to order to first of all know what is the capacity that you need, how many machines, what is the network bandwidth, what is the storage requirement, and again, back to the resources set, how many network, how much network, what is the bandwidth, how many computers, storage, and so on. So basically, you need to know it in advance to order it, and it usually takes something like between few months until you get it operated, and only then you can start working on it. This is what we call a long lead time, the lead that it takes you to get the time that it takes you to get the computing environment in order to enable your business. Another challenges is that it's security, interoperability, and portability. Now, security is probably very obvious. I guess that you hear the news. If you don't have the compute resources under your supervision, it means that any data that you have there can find new owners, right? Because some things can be compromised. So this is another challenge that cloud computing has, as opposed to I have my computer here at home and I know where all is my data. Does it make sense so far? Good. And now I'm going to talk about essential characteristics. Um, so how we define what it's not how we define what are the characteristics that are required that cloud computing has, and this is, by the way, a not so important slide, but I do want to call it out because it helps understand what can you as a user or as a potential customer can get from cloud computing. And as I called out before, on-demand self-service, broad network access, resource pooling, and rapid elasticity, this is one of the essential, these are few of the essential characteristics. And there are several service models. And again, I wanted to call out here is that I believe, but this is my opinion and I don't have any proof for that, is that those service model will converge in some ways in the future. But we're gonna call them out anyway. So cloud software as a service, which is something that you have an application, okay, and you want to get a full service on it. You don't want to deal with the software. You don't want anybody call you in the middle of the night and tell you, hey, your software is down. You want that somebody gonna take care of that, and you just pay for the service. For example, if you are an organization that pays salaries, so there is a SaaS service, software as a service, called ADP, that take care of all the salaries and the benefits that employees get. So as an organization, I don't really manage any of these things. My employees will go to this website and they will register there. There will be some kind of a protocol between me and the SaaS provider, but essentially I am not going to be in the business of developing services that handles benefits for employees, because this is not my core business. I'm selling shoes, if that makes sense. Now, the second thing is platform as a service. Cloud platform as a service refers to, okay, I know how to write code, but my code is focused on the business logic only. Okay, I don't want to talk about how this application will scale. For example, you made a great point about RDS. In the old days, it's not so old, but but when I was a engineer, when I started, I was a DBA, and as a DBA, I used to install and deploy Oracle database clusters, and it was a substantial, it was a big part of my work, the administration of the database. And there is a lot of consideration when you are building a cluster. It needs to be within some kind of an infiband because there is some replication between the two nodes. And the point that I'm trying to convey is that it is required to have a set of skills and knowledge and resources in order to run these things. RDS simply solve all these things. All you need to know is just SQL, right? You have RDS and you just have SQL. You know how to populate the data and you can query it, you can delete it, you can update it. You're completely agnostic to how it is managed, how it is handled. You're just using the platform. So this is the PaaS example. IaaS, which is referred to infrastructure, as a service, it's basically VMs. This is what we are going to do in the first or the second part of the course. We are going to provision VMs. We are going to use an open source software. We are going to download those software and compile it against those VMs, and eventually manage the entire stack of the service. So and I think that the next slide is a great analogy. Car as a service. I will not spend so much time. Please take a look at that and let me know if it makes sense. It's not super accurate, but it gives a good idea of how to look at the characteristics that I called out a minute ago. Now, having said that, after we discussed all the three models, there are several deployment, more precisely 4 deployment models. One is a private cloud, there is a community cloud, public cloud, and hybrid cloud. Public cloud is what we are going to focus in during this course. Private cloud is an option that is reserved for large organization that wants to basically deploy their workloads, but their workload scale is huge. So if they will run with the public cloud, it's just going to cost them more than that, because it's basically a method to optimize your cost. Okay? And sometimes you want that your data and you want to have a full control of the infrastructure of the entire stack, as I called out, of your service. Yeah, that's about it. Community cloud, which is governed mostly by OpenStack, is an open source services that one can basically download from the internet, build a private cloud, and deploy it there. Okay, this is a community. It's basically the features of this cloud model is emerged by the users, by the admin, by the engineering, rather than by a business. And hybrid cloud is basically the hybrid solution of more or one or more of these 3 options. I'm sorry, say it again. If you are audible, what are you saying? Yes, I can hear your voice properly, yes. Yes, exactly like that. So you can do both. You can do both. If you are big enough, you can say, okay, I'm a PaaS. I'm a platform as a service. I build my own data center, and I'm taking the software, okay, the database. I'm running it, okay? And every user that wants to use my platform, I'm giving him a username and password, the credentials that they need. I create for them a schema, an isolated schema, and then with this thing they can go and actually use my platform, and I get money for that, for this work. Now, as you can understand, basically, if you do it, you don't need to worry about who will install the database, who will install patches on the database, who will make sure that the database works. This is going to be the PaaS provider work. Does that make sense? Can you hear me now? Yeah, I think I lost you for a while. I have a difficulty to hear you. I have a difficulty to hear you. So here is my suggestion. You should, when you are attending to a lecture, I will strongly suggest and advise you to be in a place where you are have a stable connection. Okay. Um, this is it's important. So if you are driving right now to your work, no, 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 don't be sorry. That's okay. That's okay. We have a plenty of options to do. We have an offline options to look at this course. So don't worry about it. So once that you have a stable connection, you are more than welcome to ask more questions. So let's move on. Cloud computing workloads are basically describing what is running on the cloud, okay? So think about it as email, photos, video storage, and an office application. This is a type of a workload. There is another offline workload that can be a synchronous workload where you have a bunch of logs that are getting generated by your service or by other services, and this data needs to be processed offline, such as MapReduce. It's a great function. It's a great example if you want to, for example, track and count all kinds of popular words for search engines. Server-side computing is easy to manage. You have a thing in the browser, and if a user found a bug, the fix can be applied on the server side, and then there is no need to distribute the fixed software back to the user, because we are all online. So this is basically the examples of cloud computing workloads. How it is running, and this is going to go in it. Now we are starting to talk about the textbook. Okay, um, the textbook call it warehouse scale computers. Basically, a warehouse scale computers, they comprise of many data centers, and data centers comprise of many racks. Many racks includes of many servers, and every servers includes many CPUs, core storages, and network bandwidth. Okay. If we look at the next slide, we can actually see the articulation of what I just described. And basically, if you look at this, this is just an example. There is no need to remember any of this. It's just so you understand what we how the basic architecture look like. Now, having said that, I would like to call out that cloud computing is not just a collection of of servers. It's not just, you know, a bunch of software and hardware that are connected together. There is a one brain that look at all these resources as a one cohesive service. And what is great with this approach is that it can be multi-tenant. If I am looking at this service, at these sets of resources, I can build a software that can say, okay, if a user wants to process a workload, you as a user can declare on what do you want, and based on this declaration, I can go and look for my server pools, my resource pools, and carve the amount of resource that you need in order to process your workloads. And the criteria can be, for example, how many CPUs you want? What do you want to run? Where do you want to run? Because if you are happy, if all of your users are in Europe, there is no point in provisioning the service in the US, right? Because you have the network latency. This is just an example of the protocol between the user and the service and the cloud service. And this is actually manifest why cloud computing is not just a collection of servers. Okay. The software and hardware run at scale across many servers, racks, data centers as single computing units. The large scale requires special designs for fault behavior, and this is going back to my initial example. If you run a service, right? Let's say that in the next homework, you will have to run a web server, right? And this web server will be a service for somebody. If this VM goes down, the whole service goes down, right? There is an implication for that, because think about Facebook. I don't know if you like Facebook or not, but essentially one of the reasons that services such as Facebook are very popular is not just about the featuring. The features are really important, but it's always available. The same goes for Google. The same goes for the rest of the popular services, because if you have a service that doesn't run so well, no matter how nice it is, or how rich it is, or how nice how rich is the feature set, you will not use it because you know that it's not working this time or something like that. So this is why it is important to take care. This is why cloud computing look at it as a cohesive story, and take care on the fault behavior and make sure that the provisioned resources are tolerant to faults. Efficiency of power and energy consumption is super important, because you will see in the textbook that the amount of demand for computing is ever growing, and as you will see, power and energy consumption is a function of the availability and the required capacity. So the more network we need, the more compute we need, the more apps we have on our phone, it's just require more energy and more carbon footprint. Another important thing is continuous deployment and continuous integration. Those two functions are basically allowing you as a server that runs in the cloud, as a service that runs in the cloud, to basically stay up to date to your users and to basically to your user and to your customers. So if you have a new version, put simply, if you have a new version, you don't have to think about how do I deploy it. You will have a system that's just going to push it and it's going to be available for you. We are going to talk about it separately later on in the course, why it is so important to have this continuous deployment and continuous integration feature. This slide talks about the data center power usage, and this is basically a good segue for the first slide, for the previous slide. And you can see here the point that I'm trying to convey here is that if you look at the pie of how much energy goes to all the things that you need in order to get the benefits from the CPU, and the networking, it's just 37, 38%, okay? Which is pretty, it's pretty low as opposed to all the operation, right? It's a pretty small fraction. So this is the point here. The point here is that I'm trying to convey here is that there is a lot of overhead in operating such service. Yeah, so it's 33% as I called out. Now, this is going to talk about the course project. I'm going to talk about it later. This is not that important for you right now, but take a look at that. By the end of the course, you will have to run some, to present some course project, but the course project will be based on some framework, and I strongly suggest that you will look at that. This is the summary, and I am going to so you have the week 2 reading. I'm going to publish also an homework, and we are going to have the first quiz in week 4, which is in 2 weeks from now. The quiz will handle a simple programming question just to keep you sharp for the coming challenges in the course. Okay? Any questions? Yes, most definitely. We're going to yeah. I'm gonna give you a practice before. A practice question, don't worry. Cool. Okay. So thank you very much, and I hope to see more people in the next session, and we will stay in touch with the Hangout chat. So please feel free to shoot any question that you have about homework or anything that relates to cloud computing, and I will be happy to answer those questions. Cool. Not email, not email. You can use the Skype chat. Not the Skype, sorry, the Google Hangout. Cool. Okay. Bye bye.